Let's start with the basics. What problem does this repository solve, and who is it for?
This repository is an exploration of what an AI-powered hedge fund could look like. It's a proof of concept, not a real trading system. The goal is to make it easier for people to experiment with AI-driven trading strategies, backtest them, and even paper trade them. It's for researchers, engineers, and anyone interested in the intersection of machine learning and finance.
Okay, what does it let someone do that was hard or impossible before?
It lets you create a complete hedge fund setup with AI-driven trading strategies. You can define the fund structure, its strategies, its risk parameters, and how often it rebalances. Then you can backtest those strategies against historical data, simulate trades using a virtual broker, and even run the fund in a live environment, though not for real money. This is a big deal because it's one of the few tools that puts the entire process, from strategy creation to execution, into a single, cohesive framework.
How do the pieces fit together conceptually?
The architecture is built around a few key components. At the core, there's a fund specification, a YAML file that defines the fund strategies, risk parameters, and rebalancing schedule. This is the desk of the fund. Then, there's a data pipeline that pulls in financial data from external sources, and a backtesting engine that simulates the performance of the fund's strategies over time. The AI models, both traditional quantitative models and machine learning models, generate signals that the fund uses to make investment decisions.
What are two genuinely interesting technical or architectural ideas specific to this repository?
One is the use of pedantic models for all data structures in the pipeline. This ensures consistency and makes the system more robust. Every signal, every trade, every piece of data is represented in a standardized way, which makes it easier to pass data between components and maintain the integrity of the system. The second is the integration of LLMs, large language models, into the alpha generation process. These models can generate trading signals based on a wide range of factors, including news, fundamental data, and even human reasoning.
How do the LLM models interact with the rest of the system?
The LLM models are used as alpha models. They generate signals, which are essentially conviction scores for specific tickers on specific dates. These signals are then used by the fund to make investment decisions. The LLMs can provide reasoning for their signals, which is important for understanding why a particular trade was made. This is especially useful for human oversight and debugging. The system handles both quantitative and LLM-generated signals, and they can be combined in various ways to create more sophisticated strategies.
What about the backtesting engine? How does it work?
The backtesting engine is built on top of a simulation broker, which mimics the behavior of a real trading platform. It uses historical financial data to simulate how a fund would have performed under various market conditions. The engine can run a backtest over a specified time period and generate a detailed report of the fund's performance, including metrics like Sharpe ratio, drawdowns, and returns. This helps users refine their strategies before deploying them in a live environment.
What technologies are used to power the system?
The system is built using Python, which makes it accessible to a wide range of developers. It uses pedantic models for data validation and serialization, which is a great fit for a system that deals with complex financial data. The LLM integration uses standard API clients, which allows the system to work with a variety of providers like Anthropic, OpenAI, and Google. There's also a focus on modularity, which means different components of the system, like the fund engine, the data pipeline, and the backtesting module, can be used independently if needed.
How does the system handle data from external sources?
The system uses a data client that connects to external financial data sources, like financial datasets. This client pulls in real-time and historical data, which is then cached and made available for use in the system. The data is stored in a standardized format, which ensures consistency across different parts of the system. This is important because financial data is often messy and comes in different formats from different sources.
What about the user interface? How does someone interact with the system?
There's an interactive textual TUI, terminal user interface, that allows users to build and manage funds directly from the command line. This is a powerful tool for building complex fund structures and testing different strategies. The TUI is a thin client that composes a fund specification, which is the same YAML file that the system reads for non-interactive runs. This means that the same specification can be used in both interactive and non-interactive modes, making it easier to develop and test funds.
What are the limitations or caveats of the system?
The system is a proof of concept, which means it's not yet suitable for real trading. It's also in active development and the project is evolving. The current version is not a persistent, always-on AI hedge fund, so it's not yet a complete solution. It's also focused on educational and research purposes, and not intended for actual investment. Users should be aware that the system is not responsible for financial losses, and it's not a substitute for professional financial advice.
What are the key features that make this system stand out from other hedge fund tools?
The system is one of the few that brings together both traditional quantitative models and machine learning models in a single framework. It also provides a complete, end-to-end solution for building, testing, and running hedge funds, from strategy creation to execution. The integration of LLMs into the alpha generation process is another standout feature, as it allows for more sophisticated and adaptive trading strategies.
Can the system be used for live trading?
Not yet. The system is designed for backtesting and paper trading, and any live trading would require additional development and integration with real trading platforms. The project is still in the early stages, and the team is working on making it a persistent, always-on AI hedge fund. So, while it's not possible now, it's something the team is aiming for in the future.
What are the potential applications for this system beyond education and research?
The system could be used by hedge fund managers to test and refine their strategies before deploying them in live environments. It could also be used by researchers to explore the effectiveness of different trading models, including those powered by machine learning. In the future, it might even be possible to use the system as a foundation for an actual AI-driven hedge fund, once it's fully developed and integrated with real financial platforms.
What are the next steps for the project?
Anyone interested in the intersection of AI and finance, including researchers, engineers, and hedge fund managers looking to experiment with new strategies. It's also a valuable resource for students and educators who want to explore how AI can be used in real-world applications.